Here we're going to continue our look at organic chemistry, but looking at the naming of compounds. There's a systematic naming process that came from IUPAC, which is the International Union of Pure and Applied Chemistry. So let's go through this then. As I said, it's this naming system for naming organic compounds. A name consists of 3 parts. It's not always 3 parts. We have the main part of the name, which is the root and the stem here. We have a suffix, and sometimes we have a prefix, okay? The root of the stem, that tells us about the longest unbranched hydrocarbon chain. For example, if I was to draw out a hydrocarbon chain like that, there'd be 1, 2, 3, 4, 5. There's 5 carbons in that chain. That's going to be really, really important part of my molecule. The next thing, which is the suffix, well, that tells me about the functional group. I might have 1 carbon and this functional group, which is a carboxylic acid. I might have another part, which is 2 carbons and an alcohol group. Okay, the last part tells me essentially if I've got a side chain coming off the main part of my molecule, like for example if I go back to this one here, I might have a methyl group there. So while there's 5 carbons in the main chain, that's still the root, but because I've got a carbon atom here coming off the main chain, I'm going to have to name that as a prefix, and because there's only 1 carbon in that little group, I'm going to call it a methyl group, but I'll get onto that in a little bit. Sometimes you may have all of the bonds in a ring system like that, where all of the atoms are bonded to each other. There's 1, 2, 3, 4, 5, 6. So while there's 6 carbons in a row, I'm going to think that's called hexane, just carbon single bonds. But because they're joined in a cycle arrangement like that, I call that cyclohexane. Cyclo being the prefix. Sometimes we use a prefix for a functional group. For example, if I had something like this, which had a carboxylic acid group, but it also had an alcohol group. We'll look at these in a minute. But here, because I've got 2 functional groups, well, the root will tell me how many carbons I've got. 1, 2, 3. So that's going to be 3 carbons in the root of the name. The suffix tells me that it's an carboxylic acid group, so that is called oic acid. So 3 carbons is propanoic acid. But because I've got an alcohol group here, it's going to be 2-hydroxypropanoic acid. Just be a bit patient, we're going to get to that name in a minute and how we come across it. Okay, but that's just an example. So now we're going to deal with the root part of the name, or the stem, counting up the number of carbons and then what we call that. So let's go through the root. If there's 1 carbon in the root, then the root is given the name meth. If there's 2 carbons, it's eth, then prop, then bute, B-U-T, then 5 carbons, it's pent, 6 carbons, it's hex, 7 hep, 8 carbons, oct, 9 carbons, non, and 10 is dec. So remember, the root just tells you the number of carbon atoms in the longest unbranched chain. Okay, so we just follow the chain along. So for example, if I look at that, there's 4 carbons like that. Likewise, there's 4 carbons there. So the longest unbranched chain there is 4 carbons, so it'll have a bute in its name. Okay, so we're going to try and remember those as we go through some of the main functional groups that we're going to encounter now. So the first homologous series we'll come across are the alkanes. Now I'll do separate videos on these later on, but the alkanes, their prefix, it could be methyl or ethyl, propyl, butyl, pentyl. Now that is usually used if we've got a side chain coming off the main chain. The suffix is ane. So if there's a molecule that is an alkane and it has 1 carbon, then it's going to be methane. If there's 2 carbons, well, 2 carbons is given ETH, or eth, and 2 carbons you can see there, 2 carbons in the molecule, it's ETH, eth, and the suffix is ane, ethane. Next, I've just got a more complicated molecule, but I count the longest chain of carbon atoms, which is 3. It's also 3 this way, if you imagine. But if there's 3 in the main chain, that means the 3 carbons is prop, which is there. It's an alkane because it's only got hydrogen and carbon single bonds. So it's propane. But because there's a substituent, which is a group that comes off a main chain, like that, which has 1 carbon in it, and it's just a carbon hydrogens with single bonds, therefore it's a methyl group. Okay, and the number 2 tells me that the methyl group is attached to carbon number 2 on my longest chain. So just to recap, we know it's an alkane, so it's going to end in ane. longest unbranched hydrocarbon chain is 3 atoms long, so that's so that's going to be a propane, but it has to be 2-methyl propane because this group here is a methyl group and it comes off carbon number 2. Now for methyl propane, the methyl group can only come off the middle carbon, because if the methyl group came off that carbon there, that would extend the unbranched chain, and so we'd create butane. So 2-methyl propane is also known as just methyl propane. The next one we'll look at is a second homologous series called the alkenes. Well, the alkenes have an ending of ene. The alkenes are when you have a carbon-carbon double bond. So that means 2 covalent bonds, and I'll talk more about that in the covalent bonding section. Okay, but a carbon-carbon double bond here, there's 2 carbons, which is the simplest alkene, because you need 2 carbons to have a double bond. That is called ethene. Next, if we extend that carbon chain by 1, there we have 3 carbons there and 1 double bond, so that's called propene. I'll talk about the alkenes in another video. The next homologous series I'm going to talk about are the alkynes, ending in yne, have a carbon-carbon triple bond. And for leaving cert, the only one you need to know is ethyne, when there's 2 carbons and 1 triple bond, also known as acetylene, used in things like blowtorches because it's extremely flammable. Now, the next homologous series are the halogenoalkanes. So these are alkanes that have a halogen or anything in group 7 or 17 attached to them. Okay, so they could have a chlorine atom here, could have a bromine, a fluorine, or an iodine. And you just name the alkane chain, but also, if there's a halogen, you put chloro in front of it if there's a chlorine, bromo in front if there's a bromine. You're usually going to have to write the number of atoms of each there are, and also the position of where it is. So, for the simplest one here, for chloromethane, also known as chloroform, we have a carbon-chlorine bond. It's a methane with basically the chlorine swapped in for that hydrogen. And that's called chloromethane. If we step up the complexity then, we have 1,2-dichloroethane. So ethane means there's 2 carbon atoms, like that. 1,2 means there's a chlorine coming off carbon number 1 and carbon number 2. So that's 1,2-dichloroethane. The next one, 1,1-difluoro-2-chloroethane. Well, we look at this stem, that's ethane, so it's just 2 carbons long. I'll stick with my skeletal formula. On carbon number 2 there's a chlorine, and on carbon number 1 there's a fluorine. There's actually 2 fluorine atoms on carbon number 1. Di here tells us there's 2 of the fluorines, and the numbers here tell us the position of the substituent on the carbon chain. The next homologous series we're going to talk about are the alcohols. So with the alcohols, sometimes there's a prefix, as I said at the start. If there's another functional group present, then it will have the prefix hydroxy. If not, then OL is just added to the end of the root name. Sometimes we have to write an AN in between the original root and the functional group. For example, for the alcohols we do that. So methanol, where there's 1 carbon and it's an alcohol, is CH3OH. Ethanol is CH3CH2OH. So now we're going to look at the last remaining 4 functional groups that you need to know for leaving cert organic chemistry. One of them is the aldehyde. This is normal root and stem, just ends with AL. Okay, again we're going to introduce the AM between the normal root and the AL. So if we have an aldehyde, which is a C double bonded to an oxygen, that C also have 1 single bond to a hydrogen atom, that is known as an aldehyde. It is always at the end of a chain. Now, the simplest one is methanol, also known as formaldehyde. The second one then in the homologous series would be ethanol, where you've got 2 hydrogens. Next one will be propanol, etc. Okay, the next functional group we'll look at then after the aldehydes is the ketones. Very similar to the aldehydes. The only difference is that the carbon-oxygen double bond doesn't happen at the end of the chain, it happens within the chain itself. And that's what differentiates it from an aldehyde. The ketones ends in ONE, standard root name, so propanone, pentanone. Here we have pentan-2-one because the carbonyl is at position number 2. And the last 2 functional groups we're going to look at are carboxylic acids and esters. Okay, we mentioned a carboxylic acid at the very start, so the suffix is oic acid and the standard root name. So ethanoic acid is also known as acetic acid, which is basically what's found in vinegar, I mentioned at the start. And the last functional group are the esters. The naming system for the esters is probably the most complicated. It comes in two parts and arises from how they're made. So they're made from the reaction of an alcohol with the carboxylic acid. The alcohol part is just given the alkyl part of the name, like there, and the acid part is given the name O8, the suffix O8. So we've got a prefix and a suffix. For example, the first one, the prefix, as there are one carbon here, is just given methyl because it came from methanol. And the second part of the name is ethanoate because there's two carbons, and that came from the carboxylic acid which was used to make it. And we'll talk a bit more about that when we deal with the esters in detail. Okay, the last one here, ethyl propanoate. Ethyl, because you can see in red there's two carbons, and propanoate because there's three carbons in that second part. So ethyl propanoate. So that's a brief overview of all the homologous series we need to know for leaving cert organic chemistry and how we name them.